morning, welcome back after a long period, and today we'll start a new unit, that is programming methodology, and the first chapter of that topic is that unit is computational thinking and getting started with Python. Okay, so the first part of this topic is the computational thinking. The computational thinking is a very important method or procedure for developing your computational power or your thinking power so that you can solve a problem, or it is very helpful for developing a power of solving problem in any kind of problem, whatever be the problem we are facing in day-to-day life. If you want to solve that problem, so using this computational thinking method or using this computational thinking procedure, we can solve each and every problem very easily and in a very efficient way. So, if you are going for the computational thinking, it is nothing than the person or the time period or the period between the problem and finding the solution. The problem and finding the solution, in between the problem and the solution, what are the processes, what are the stages or what are the phases or steps we followed, that steps or that stages is known as your computational thinking. So if I am going for computational thinking, again the computational thinking is divided, or it is made up of three different pillars. These are known as four different pillars or four different parts. These are known as the pillars of computational thinking. And the first pillar is decomposition, second is pattern recognition. This is also known as data representation. It is pattern recognition in case of a generalized process. If you are using any kind of problem, if you are solving any kind of problem in day-to-day life, that may be a pattern recognition. But in case of when we are doing a computerized problem solving process, and that time it may be called as a data representation. That means both recognition of pattern or data representation is the same thing. The third thing is the abstraction, and the fourth thing is the algorithm. So let's go for the first pillar of the computational thinking, that is your decomposition. Decomposition is nothing than dividing a large or complex problem into smaller parts or some division which can be simply solved. If you have a large problem, then a better idea to decompose that problem. That means at whole we are not going to solve that problem. First, we divide the problem into smaller parts which can be simply solved or which can be solved using a very simple method. That process is known as the decomposition. This is the first step of your computational thinking. That means whatever be the problem we have, we should divide that problem into smaller parts. The second is pattern recognition. This is the most important part, or this is the important part in case of your computational thinking, that is recognizing the pattern. Recognizing the pattern or pattern recognition, that means we have to find some similarities between all the divisions or all the parts. Those are made up by decomposition. A problem is divided into smaller parts or divided into simpler parts. Now we have to find out some similarities, or we have to recognize some pattern or some relation between those small or those simple problems. Then abstraction. Abstraction refers to the process in which we are focusing on the important data or neglecting or ignoring the unnecessary details or over details of that particular problem. In any problem, we have some amount of data which are actually being used to solve that problem, but along with those data, we have some other informations or other data which are not so important for that specific problem. So abstraction is a kind of filtration that filters the important data for solving a particular problem. And the last pillar is the algorithm. In case of an algorithm, it is nothing than a step-by-step solution of a problem. Now we have the decomposition, that means we have smaller problems and simpler problems. We recognize the pattern, that means what are the similarity between that problem has been recognized. Now we ignore all unnecessary informations or data. Now we have to develop a step-by-step process for solving that problem, that is known as your algorithm. Now these are the four pillars of your computational thinking, or these are the four subdivision of computational thinking. Now let's go for an example so that this thing can be easily understood. Okay, now come to this side of the board. Now here we have a simple problem that find the sum of all numbers from 1 to 20. Now what happened? Generally when you have this question, you start writing something like this: 1 plus 2 plus 3 plus 4 dot 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 up to 20, or plus 20 you have to write, and you start adding all that. Is 1 plus 2 is equal to 3, 3 plus 3 is equal to 6, 6 plus 4 is equal to 10. Like that we are going to solve this problem. Now how can we decompose this problem? This is a very simple problem, or is a very simple mathematics. Still we can decompose this process. How can we decompose this process? Simply we can write down like this: 1 plus 2 is equal to 3. Now up to 2 we have calculated, so 3 plus 4 is equal to 7, 5 plus 6 is equal to 11. Likewise we can 19 plus 20 will be the last term, that will be 39. Then we can add all these terms so that we'll have the final result, that is nothing than 1 plus 2 plus 3 plus 5. Now this is known as the decomposition. That means at whole we are not solving the problem, we are dividing the problem into smaller parts, and we are calculating each part separately, or we are solving each part separately, and we are integrating the result so that we'll have the final result. Now in case of pattern recognition, what happened in case of pattern recognition? Now see, we have already subdivisions. Okay, now I can make a little bit different kind of calculation of that by adding the first number with the last number, second number with the second last, third with the third. This kind of calculation we can also do. And when we are doing this kind of calculation, then what happened? 1 will be added with 20, 2 will be added with 19, 3 will be added with 18. Now what happened here? 1 plus 20, 21. 2 plus 19, 21. 3 plus 18, 21. 4 plus 17, 21. And like this we have the last thing, that is 10 plus 11 is equal to 21. So these are some similarity of these subdivisions. When we are subdividing the problem, or we are decomposing the problem, then we have different kind of calculation, or different kind of solution, or different solutions. Now these are some similar solutions which you can do. Now total we have 10 numbers of these similarities, or 10 number of this kind of patterns, because total we have 20 values, and here we can have only 10 values. If I am writing the complete one, then what happened? The next should be 5 plus 16 is equal to 21. The next is 6 plus 15, again 21. 7 plus 14, 21, and 2 more I am writing in the below, that is 8 plus 13 is equal to 21, as well as 9 plus 12 is equal to 21, and the last one is 10 plus 11 is equal to 21. Now how many subdivisions or how many patterns we have? That is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 patterns. That is exactly half of the figure 20. Now what happened? We can directly do like this. 21 into 10, that will be 210 or 210 will be the result. This is how we can decompose and we can find out the patterns. Now if you add like this, you will get the result as 210. If you are doing like this, then also will have the result 210. But this is a easier method. Now the question in our mind is that, suppose this is the easier method we can do or we can solve through this method, then why should we go for this kind of patterns, or why should we go to search this kind of pattern, which is nothing than a headache of finding this kind of pattern. Yes, it is a headache for finding this kind of pattern, but the merit of finding the pattern is that. Now suppose in order that we have to find out the sum of all number between that is from starting from 1 to 100. Then what happened? Directly we can calculate like 101 into 50 will have the result. Get the point? Because in this case what happened? 1 plus 2, that means the first digit and that last digit of the first number and the last number will be added, and it will be multiplied by the half of the last digit. Doing the same formula or using the same formula, we can find out the sum of any series of number. So this process is known as your pattern recognition. The next test is the abstraction. Now here we have the abstraction also. When we are recognizing the pattern, now we have the pattern like this. Now what happened? Except this, there is a lot of other data like 1 plus 2, 3 plus 4, 5 plus 4. Now in case of this particular kind of solution, this information is completely useless now. This is not so important for calculating this kind of calculation. Now we have to ignore this part of information from our mind and we have to focus on this kind of calculation or whatever we are finding in pattern matching or whatever be the formula I am finding. Using that formula only we have to calculate. Now how to find out the formula I told you? Now that is 1 plus n. Suppose n is the last number. 1 plus n into n by 2 should be the formula. Now we should concentrate or we should focus on this formula. Except this formula, we have to ignore all other information and all other steps. That is known as abstraction. Now the last step, that is the algorithm, which is nothing than a step-by-step solution for that particular problem. Now when we are writing a step-by-step solution, either using your pen and paper you can solve this problem, or using an algorithm you can solve this problem, or when we convert that algorithm into some computer instruction, that become the code or that become the program. Now come to the algorithm. In the first step we have to find, suppose in step 1 find 1 plus n. In the step 2 we have to find n by 2. Now suppose find n 1 plus n, let it be m, and find n by 2, let it k. Now find the result. In step 3 we are finding the result that is nothing than m into k, whatever we're getting the value, that will be the result. Now this is known as an algorithm, and this much of thing is known as computational thinking. Before solving any kind of problem, we should go for computational thinking. Okay, now whatever example I have given to you, that is a very simple thing, or it is a very simple problem for solve. But when we are going for programming or coding, then we have large number of instructions. We have to write down large number of instructions, and we have to solve many kind of calculation, like arithmetical calculation as well as the logical calculation. In that case, this computational thinking is very useful for developing your power of solving a problem. That's much for today. Thank you and have a nice day.